in this question, question 7 here, it asks us about hydrofluoric acid. And hydrofluoric acid is a weak acid. It's listed in our data booklet. It's below the hydronium. So hydrofluoric acid is down here. We know it's Ka from the table here. But it's asking us to calculate the hydronium and fluoride concentrations. And so when hydrofluoric acid is put in water, it'll produce fluoride ions and hydroniums. But this is going to be less than 50% because it's a weak acid. And this is the acid, this is its conjugate base, this is the base, this is its conjugate acid. And they're telling us that the concentration of the hydrogen fluoride is going to be 2.0 mole per liter. Now, they're asking me to write a Ka expression. So the Ka expression is going to be the fluoride ion times the hydroniums divided by the hydrofluoric acid. That's my Ka expression, so that's the answer to A. And then they ask for the hydronium and fluoride concentrations. Since the Ka for hydrogen fluoride, and I read this off of the data booklet, is, so the hydrofluoric acid's Ka is going to be 6.3 times 10 to the negative 4. I can calculate the concentration of hydroniums using the square root of the Ka times the concentration of the hydrofluoric acid if the concentration of acid, or the concentration of the acid divided by the Ka is greater than 1,000. So if I take 2.0 and divide it by the Ka, which is 6.3 times 10 to the negative 4. Since this gives me 3,000, this allows me to use this formula. And the hydronium concentration is going to be equal to the square root of 6.3 times 10 to the negative 4 times 2.0 mole per liter. And so I probably should have some units for that. And that's going to give me the hydronium concentration calculation. So I'm going to take the square root of 6.3 times 10 to the negative 4 times 2.0, and it gives me 0.03549, blah, 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 blah. So the pH, though, is and that's mole per liter, and the pH is the negative log of this number. So negative log of the concentration of hydroniums, which is 0.03549 mole per liter. And so the negative log of 0.03549, it's giving me a pH of 1.44989. Well, this had two significant digits, and significant digits for pH follow the decimal, so it'll be 1.45. Okay? And that's how we're going to calculate this. But doing the calculation is one thing. Recognizing that you have an initial concentration and the Ka, and that they are asking for the hydronium ion concentration or the pH, is how we're going to approach this question. So you need to recognize that, not just be able to do the calculation.